Okay, so consider this given problem statement. The number of elements present in this particular set. So set is A over here, and it contains the tuple A comma B such that it follows this particular equation, that is 2a square plus 3b square, that is equal to 35, and A and B both belongs to the set of integers, right? So our given equation is 2a square plus 3b square, that is equal to 35. Now when b is equal to 0, if I consider this fact, then in that case 2a square, that becomes equal to 35, because we have substituted the value of b over here, right? Now from this equation it is clear that there is no such a that belongs to set of integers, right? So no such integer will satisfy this particular equation. Next, if I consider for the value of b, that is for both positive 1 as well as negative 1, for that I can write plus minus 1. For this particular equation, if I substitute the value of a as positive 1 negative 1, so in that case 3b square, so in this particular fact 2a square, this becomes equal to 32, and on resolving this particular quadratic equation, we get a belonging to the set. So this is 32, so 2 times 16 is 32, so this leads to a square as 16, and this clearly shows that a will belong to the set where minus 4 and plus 4 will satisfy this particular equation, correct? So from this we got four distinct values: negative 1, negative 4, positive 1 and positive 4. Next, when this b is equal to plus for both positive and negative 3, if I consider, so in that case I can write here 2a square, that is equal to 8. Now from this we can write that a square is equal to 4, and from this we can say that a belongs to the set which will contain negative 2 and positive 2 upon solving this particular quadratic equation. Now when b is equal to, I'll consider both positive and negative values 4, so in that case I can consider 2a square, that is equal to 23, and from this we can clearly observe that there is no such value of a that can take a integer and that will satisfy this particular equation, that is 2a square, that is equal to 23. So from this we can clearly observe, and we can write here that a is equal to, so a will contain this kind of tuples, right? So that is with plus minus 4 when the input is given for negative and positive 1. In the similar way we can write it for 2 and 3 as well, right? So positive and negative 2 in case of this positive and negative 3. So these are the 8 numbers. So these are the 8 distinct members that we can have. So one is negative 4, negative 1, then next one plus 4, minus 1 and so on. So like this represent 4 combination, right? Considering negative, 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 positive, positive, negative and positive, positive, right? So in that case 4 combination from here and 4 combination from here. So from this we can clearly conclude that number of elements present in the set A, that will be equal to 8, and hence the solution for this particular problem. So I hope it is clear to everyone.